Welcome to all our listeners worldwide. This is Gilat's webinar, and I am Dorit Oren, Director of Product Marketing at Gilat Satellite Networks. As many of you know, Gilat is a leading global provider of products and services for satellite-based broadband communications. Gilat is in this business for over 25 years, with over 1 million terminals shipped to more than 90 countries. And Gilat has over 20 sales offices throughout the world. Gilat is a strong player in the consumer broadband market worldwide. This year, multiple hubs and thousands of terminals were deployed at a diverse range of ISPs throughout Europe and Asia. As an example, we received this year a hub expansion order from our partner SES Broadband Services. In today's webinar, we will focus on the untapped market of home broadband in the developing world. For this purpose, Gilat has introduced an innovative solution which has led us to today's exciting webinar that we have titled, Changing the Equation for Reliable Fixed Broadband. In today's webinar, I'm pleased to be hosting Yoram Ofri, Gilat's Director for Cellular Markets. First, a few procedural issues. If you would like to ask questions during the webinar, please type them into the chat box. We will take as many questions as time permits at the end of the presentation. If there are questions that we don't get to during the session, we will make sure to get back to you later. Also, don't be concerned in case you miss something. The webinar is being recorded and will be available on Gilat's website for further review. Okay, so let's go over the agenda of today's webinar. We will discuss the need for broadband and will review the current types of solutions and their challenges. From here, we will introduce Gilat's innovative solution that we have named SkyEdge 2C Libra. This is a new member to our SkyEdge 2C family of products. We will go over the benefits of this solution for various stakeholders, including the mobile network operators, the internet service providers, the satellite service providers, and satellite TV providers known as DTH providers. Yoram Ofri will then dive deeper into our solution. He will go through the solution components, discuss how it works, and also will highlight Libra's features and benefits. And then finally, I will summarize and take questions. Okay, so let's turn to slide 3. Look at the pie chart representing internet connectivity in households worldwide. Look at the left side of the pie chart, clearly showing that in 2013, just last year, more than 50% of households do not have internet access. But the more remarkable point, in my opinion, is that 90% of these unconnected households are in the developing world. Let's look at how home broadband is being addressed today. The great majority of internet access from the home is delivered via the following 3 possibilities: via fiber, via XDSL, or via cable modem. However, there is a market, primarily in the developing world, in the underserved areas, where there are other common solutions for bringing broadband to the home. There are solutions such as wireless radio, cellular, or satellite. Let's look briefly at the pros and cons of each of those. On slide 5, now talking about the wireless radio, and we'll take WiMAX as an example. This solution has the following advantages. The CP installation and activation is quick with relatively low capital expenditure. However, when we look at the cons, we see that this solution is not easily scalable, and often the backhaul is not available. Let's take an example. For example, in rural areas, where the WiMAX tower may be placed on a hill, however, no point-to-point microwave link can be established easily. On slide 6 here, we see another very relevant solution. This is the cellular network for delivering broadband to the home. Here indeed, we see huge coverage of the cellular network worldwide. And also, we see a great advantage of consistent service provided in various environments to the end user, such as when the user is at work or at home or even on the go. However, this great advantage of the cellular network to be used for broadband to the home is greatly compromised because of the following reasons. First, there isn't enough bandwidth to deliver broadband service adequately to all subscribers. And often then, the performance is unacceptable. The broadband speed is too slow and often simply inconsistent. Very frustrating. Often slow data transfer speeds make internet use an unappealing proposition. When the mobile network operator cannot provide sufficient bandwidth, or the end user is too far from the cell, the user experience is very poor. Also, congested networks degrade the user experience and create customer dissatisfaction. So this solution really has a very strong pro and a very strong con. The next slide, slide 7, is about satellite for home broadband. And this is another solution that is used widely in the developing world for broadband to the home, as I said. And we see here delivery of very high performance broadband to the home, which is what people want, and it can be quickly deployed almost anywhere on the globe. However, in some regions of the developing world, the VSAT cost is too high, it's simply not affordable. Well, Gilat has conducted research and performed some studies to address this need. Gilat has found that consumer broadband penetration is highly dependent on the VSAT CPE and installation prices. We have found this to be true in the developing regions, as you can see on the chart. Look more carefully now at this chart in front of you. The blue represents the CPE cost at, say, X dollars, and the green represents half that CPE cost. Now see on the chart areas like Eastern Europe, Latin America, Asia, Africa, and the Middle East. In these areas especially, it is clear to see that the predicted fast growth of the subscriber base is due to a significant cost reduction of the CPE. I'd like to make a point that these regions are often cash-based economies, and this means that the prepaid model is the way business is done. And in that situation, terminal subsidies are not an option, and this directly connects to this high influence we are seeing of the cost of the terminal on the buying habits. Hundreds of dollars in a one-time payment in these areas is simply not an option. So on the next slide, what if we could take the best of both worlds, of the cellular and satellite, in order to solve this problem, or in order to bring a solution to the vast amount of people in developing areas that don't have broadband in the home? Recall that cellular has ubiquitous coverage. So see this chart here, for example, from ITU World Telecom. It shows that even in the developing world, mobile penetration is a little bit over 89%. However, the industry must find a way to address the poor broadband performance to the home. In other words, they have mobile, primarily voice, and some are attempting to use broadband, but this is not acceptable. Now let's take from the satellite broadband solution Now let's take from the other side, from the satellite broadband solution, and see how easily it can provide the required performance anywhere most rapidly. However, the problem here is that the VSAT CPE cost is too expensive for some populations. On the next slide, we see that to answer this need, we have taken the best of both worlds, of the cellular and satellite. And Gilat has built a hybrid terminal called SkyEdge 2C Libra doing exactly that. Gilat has slashed the end-user CPE cost dramatically. In designing Libra, we have capitalized on the asymmetrical nature of the home usage data traffic. Since consumers download much more than they upload to the Internet, using satellite for the download and cellular for the upload is a clever solution. The Libra terminal will answer the performance needs at half the price of a two-way VSAT. This way we can give the underserved areas in the developing world broadband connectivity at an affordable price. And that is why we are calling this webinar Changing the Equation for Reliable Fixed Broadband. See now on slide 12 two charts, two illustrations showing possible networks using this concept that we're calling Libra, our hybrid VSAT. Both diagrams use the Libra SkyEdge 2C terminal at the home. Both use the satellite link for the download direction and as such receive up to 20 megabits per second internet download speeds. In the upload direction, however, we have two options. First, look on the left. We see use of the existing cellular network here. See the red circle. This is for the upload direction. And the second option on the right, again circled in red, is the XDSL solution for the upload. In both cases, the infrastructure at the location is being used for this hybrid solution. In both these examples, the upload speed is significantly slower than the download speed, however, more than sufficient for the home user. Okay, so Gilat has introduced an innovative hybrid satellite cellular terminal to provide high-speed broadband access. Libra leverages existing networks and provides growth paths for MNOs, ISPs, satellite service providers, and DTH providers. Let's spell out the value proposition for each. Okay, on slide 14, this is the Libra's value proposition for MNOs. So Libra, the hybrid terminal, allows the MNOs to expand their reach by using their existing infrastructure. They can utilize their current 2.5G or 3G network to offer broadband at high speeds of up to 20 megabits per second download without congesting their network. Note that this is true even in a 2.5G network with upload traffic at only tens of kilobits per second. This way, by offering end users a low-cost, high-performance VSAT CPE, the ARPU can be increased and customer loyalty sustained. On the next slide, slide 15, we're addressing now the value proposition for ISPs or satellite service providers. For them, look at the diagram here of both the options that were described before. The upload channel may be via the cellular network or via XDSL. The current network performance distance limitations can be boosted with our solution. The ISPs can increase revenue and customer loyalty with Libra. I'd like to also add that the installation of the one-way VSAT is quick and easy. Again, a significant benefit to the ISPs. On the next slide, on slide 16, we're talking about the value proposition for the DTH providers, direct to home, those that are providing TV over satellite. This is another market that can enjoy the Libra solution. Here, the current satellite infrastructure can be leveraged for an additional service. In other words, giving the DTH providers the ability to participate with triple play. Look here at the diagram. You see here an additional brown line in the direction from the satellite to the home. This is the DTH service. And it's running side by side with the broadband service. Note that the same antenna and LMB can be used for broadband and DTH services. Now we've come to the point in the webinar where we're going to take a deeper look at Gilat's hybrid solution that we're calling SkyEdge 2C Libra. And Yoram Ofri, Gilat Cellular Market Director, will now discuss the solution's components, features, and benefits of Libra. Please, Yoram.
Thank you, Dorit. So we first look at the right side, and we see this outdoor unit, which is the antenna, same antenna we normally see at satellite TV, direct-to-home TV. So we use the same antenna and the same LNB, called often LNBF. We also have the indoor unit, Libra satellite router, which is a relatively small box, and we see a standard cellular dongle that connects on the USB port of the indoor unit. Actually, the indoor unit has 2 USB ports. So let's look at the bullets over here. So we install a low-cost satellite reception terminal, or use existing, if there already exists, existing DTH antenna and existing LNBF at the customer premises. This antenna will provide a capability to work up to 20 megabits per second via satellite. The antenna size is typically 60 centimeters or 75 or 90 centimeters for KU or KA. We don't see television on KA, but we definitely can use our Libra with KA satellites. We connect a standard cellular USB dongle to the indoor unit, which allows the connections that you see from the home to the cellular in the diagram, and through the cellular to the hub. So this is achieved with this dongle. Actually, you're going to have 2 USB ports, so you can have actually, even if needed, 2 different MNOs that serve your service or any other application of the USB. Of course, there's a SIM card inside the dongle. So upload traffic goes through the cellular network. Traffic is received at the satellite hub, at the hub of Gilat, and then handed over to the internet, and then the download traffic from the internet goes to the hub and directed through the large hub antenna to the satellite, and from the satellite to the small one-way antenna. And this is the way we have part of the traffic over cellular and part of the traffic through the satellite. And then the big thing here is that the traffic through the satellite is much larger, in very high traffic. Let's look at the main features. So we use hub, which we call SkyEdge2C hub, which is a carrier grade hub. You can install and take out and plug in components like cards, boards into the chassis while it's powered on, and all components are redundant, and there's a lot to be said, maybe in a different webinar about the SkyEdge2C. We're very proud of it. Integrated with the SkyEdge2C hub is the Total NMS, is the management system that can report about unexpected phenomena, about alarms, and can show the network visits that are up, visits that are down, etc. A part of the solution that is integrated into the hub is the usage-based service definition system, and we'll talk about it later. We improve user experience with embedded TCP acceleration and HTTP acceleration, which we will talk about in a moment. So the bandwidth efficiency of our download direction is extremely impressive. We use DVB S2, which is kind of the industry standard. This goes together with ACM, adaptive code and modulation. So when it's sunny outside, we use 4 bits per hertz, meaning we use the space segment very efficiently. And when it's raining, then automatically the mode code will change, maybe to 8 PSK, even down to QPSK, and the particular throughput for a few minutes will go down, but at least service will continue, and still customer will have totally that they will have a good experience, user experience. Please go ahead. So the Total NMS, let's talk about it a little bit. It's a centralized management system for multi-gateway network. So it supports hundreds of simultaneous web-based sessions. And it has standard northbound interface to OSS, BSS of the customer. For example, something for defining the service like prepaid service and postpaid, and etc. So this is where we use the accounting and quota management. And of course, there's alarms and statistics and graphs and reports. You see in the picture here in the right side, you see alarm is open or alarm is closed, and other things that are in this versatile tool, the Total NMS. It also allows multiple ISP management. So one ISP can see his 2,000 VSATs, their status, and another ISP can see his 5,000 VSATs and manage them and see what's going on with them, with how much they exhausted the budget, the gigabyte budget, and how much more they have, etc., etc. So the users-based service of Gilat is really unique. Actually, I can talk about it a day or two, because it's so sophisticated and yet so simple to use for the ISP. It's good for prepaid and for postpaid. This is important. What you see on the right side on the top is a service based on maximum information rate. So a user who buys, let's say, 5 gigabytes per month will start using it, and when he reaches about half of it, meaning 2.5 gigabytes, his speed will fall down to about half, and he will continue using his megabits per second and more and more of the gigabytes. And then if he reaches the end of his quota, he will be redirected to a walled garden where he can only buy what is called top up. He can put more into his usage capability and serve more. Or if he doesn't want, then he can wait until the next month, and if it's a prepaid, he can anytime buy more bandwidth. Another approach is the service based on priority. So it's not based on MIR, it's based on priority. So we simply share the total bandwidth which is available on the downlink, share it between different users, but different users that pay differently, they get different service level. So you see the three lines that are going down and down, but it all depends on the amount of bandwidth which is available at a busy hour, and the priority of one against the other. Just give you another example of a sophisticated application is the free usage time zone, we call it. So an ISP can define that at certain times he's not counting the bytes. The bytes still come, and he's still getting very high speed, like 20 megabits per second, the user, but because it's 2 o'clock at night, this is free for him. So he's more satisfied, so it's more competitive against other solutions that are offered in his area. Let's talk about acceleration. So the issue of TCP acceleration is known to people who use satellite communications. It's all start with the TCP limitation, which is started there like 30 years ago when this standard was defined. The TCP definition of the header and the behavior, etc. So TCP has a limited amount of bytes that can be sent before there is an acknowledgement received from the other side. And if you use a large pipe of 20 megabits per second together with delay, and there's round-trip delay of about 600 milliseconds associated with satellite communication, or when it's Libra, it's like 300 milliseconds, something like that. With this, together with the high speed, then we very fast reach the maximum limit of bytes that can be sent without being acknowledged. Then what we do is sometimes it's called TCP spoofing or TCP acceleration, that we handle in each side. In the side of the VSAT and in the side of the hub, we handle the acknowledgement as if it's the end of the TCP connection. And then we manage our own buffer, our own protocol that take care of transferring from one side to the other, and we achieve that there's no blockage. The blockage that is associated with TCP is gone, is disappearing. Another feature that is rarely offered by our competitors is the HTTP acceleration and optimization. Where when we identify that there is a request, a GET from in HTTP in internet, we just simply kind of gamble and or sophisticated choice of bringing more and more information to the hub from the internet site, from the server of the particular application that the user wants to see. We download and download more and keep it at the hub and send it down, in the down direction. What do we achieve by that? We achieve that the up direction is not requesting so much. It's requesting less because we already delivered information to the user at home. It's already there. So no need to ask for it. So it reduces the amount of bandwidth that is needed in the uplink direction. And this is extremely important in our case, in the case of the one-way, because in the one-way we are talking specifically about cases where the up direction, the uplink direction, is very limited in bandwidth, sometimes under 100 kilobits per second, and still we want to provide 20 megabits per second down. So reducing the uplink requests is really a gift here. Okay, now we come to the summary, so Dorit will speak to you again.
Thank you very much, Yoram Ofri, for the deep dive. Now I'd like to just summarize the webinar and then we'll take a few questions. As we saw in the beginning, for the home broadband market in the developing world, we see a huge opportunity of an untapped market. I'd like to emphasize that Gilat has changed the equation by introducing a hybrid low-cost, high-performing VSAT CPE. Gilat SkyEdge 2C Libra is directed at the underserved market in the developing areas of the world with the mission of bringing broadband to the home. The MNOs, ISPs, and DTH providers have much to benefit from Libra. This is Gilat's innovative solution that can provide high-performance broadband service to end users, expand network service by leveraging existing infrastructures, and provide CPE VSAT at half the price of regular two-way VSATs. Thank you very much. Now we have some time for questions, so please bear with me for just 1 second. Okay, the first question, can Libra work with a GSM network where the GPRS is the return channel? Yoram, can you please take that?
Yes, it's a very good question because we still find in the developing countries, we find the GSM and GPRS, not so much 3G and 4G. So speed with GPRS is limited normally, not theoretically, but normally what we really find is some tens of kilobits per second, like 50 or 60 or 70 kilobits per second. And in most applications, especially surfing the internet, this is good enough because even with 60 or 70 kilobits per second up direction, you can have a response from the server that you applied to and requested information from this server to download at speeds of 10 megabits per second or 20 megabits per second. Remember that we are doing HTTP acceleration, as I explained earlier, so the real traffic required from the up direction is very low thanks to automatic acknowledgements that we provide in TCP and other things like that. So yes, I'm really excited about having GSM working with our hybrid and providing tens of megabits per second.
Thank you. We have another question here. It's a pretty short answer, but maybe Yoram can elaborate more. Can we use the same hub for Gemini as well as Libra? So the answer, of course, is yes. Our hub is a multi-application, definitely has many VSATs, and Gemini is one of them, is a much faster two-way VSAT. Let me, though, see if Yoram wants to add.
Yes, thank you. Very good answer. But I just remind that we use DVB-S2, which is standard. So we have it for quite some time. We have the SkyEdge 2C supporting Gemini, but now we support Libra as well, but still the same DVB-S2. There's nothing new here. So why not use a network of a few tens of thousands of Gemini and a few thousands of Libra, and use the same hub, the same redundant hub.
Thank you, Yoram. I'll take one more question here. Please explain if the one-way low-cost antenna used only in the case of combined DTH and broadband. Okay, I'll take this. I'll try and clarify this. No, the answer is not at all. As a matter of fact, the one-way low-cost antenna is used for download either for broadband or also for broadband along the DTH service. Okay, I hope this is now clear. The upload direction is handled in all cases by either the cellular or XDSL. I think we're going to conclude here. I'd like to thank Yoram Ofri, my colleague here at Gilat, and of course I would like to thank you all for attending. As I mentioned, the webinar is being recorded and will be available shortly on our website. Enjoy the rest of your day. This concludes the webinar for today. Thank you.